Hello guys, so the topic that we are going to see today is recursion. So firstly, what is recursion? Recursion is the process whereby a function can call itself either directly or indirectly. Okay, so in this recursion, what we generally try to do is we try to represent a problem in terms of one or more smaller problems. Say we have an input sample that is this big. Okay, what we try to do in recursion is we try to represent this input size into smaller and smaller problems, okay, until we reach a problem whereby we cannot reduce it anymore. Okay, so in recursion we try to represent our problem in terms of smaller and smaller problems until we reach a position whereby we cannot reduce it anymore. So there are some generalized approach, there is a generalized approach in solving this recursion problem or implementing recursion. That is what I like to call this IBH, that is the induction, base condition and hypothesis problem. So for every problem that we are using recursion to solve, what we do is we define a base condition, okay, and then we have a hypothesis or an induction. Okay, so that is how we define our problems in recursion, okay, while solving our problems. So we will see the use of IBH in some of the examples that I'll show you now. So some examples I have listed now is the printing 1 to n. We will do this by recursion. This is very easy. Then we will do the factorials problem. Okay, how to implement a recursion using factorials. This is also very easy. And the height of the binary tree, if we want to, we can also find this through recursion, but this is a bit advanced, so I will show this to you later on. Okay, so let us see the example one, which is printing 1 to n using recursion. Okay, and we'll be using the IBH approach as well, so you will get a better idea of what IBH is. Okay, so let's move on. Okay, so in our example one, what we are doing basically we are trying to print 1 to n, right? We are trying to print from 1 to n, right? So here I have defined a print function, okay, and in this print function I am sending the value n, right? So n is the value that I want to print until I want to print from 1 to n. Okay, so this is the last value that I'll be printing. Okay, so say for example I have sent 5, okay, the value 5 in my print function. So let's see how I have defined the print function. So initially what I did was I have kept a condition to check if the value of n is less than or equals to 0. If it's less than equals to 0, then it will return. Okay, and this thing that I have done here, this is the base condition. Okay, then what I do is I again call the print function. So I am in the print function, right? But in this print function I again call this print function and reduce the value of n by 1. So this is recursion. Okay, so I am what I am doing here, I am recursing this. Okay, so if you are calling a function from that function itself, okay, that is known as recursion. So this process, this line that I have written here, it is the hypothesis. So the hypothesis is how I'm recursing my function. Okay, then the next line that I have written here is cout. That is also my printing printf in C, and cout is in C++. So here what I'm doing is I'm just printing the value of n. Okay, so this printing value is known as our induction process. Okay, induction method. So since we are familiarized with the syntax now, let us see how this process is being done, how we are printing from 1, 2, 3, 4 up to 5 using this function. Okay, since we have sent the value of n equals to 5, we will be getting this as our output, right? So how are we doing this? Let us see this. Okay, so let me erase this now. Okay, so as you can see, when I have sent 5 here, what it will do is it will check the base condition. So does it satisfy the base condition? Is 5 less than equals to 0? No, it's not. So what it will do, it will again call the print function. Okay, and how will it call the print function? It will reduce the value of 5 by 1, right? So after it calls the print function by decrementing its value by 1, now the value of n becomes 4, right? So now here the state of n becomes 4. It's changed from 5 to 4. Okay, So again it will check the base condition, but sees that it is not satisfying the base condition, and again it will go to the print function, print calling function here, right? So what it will do is it will again decrement the value of 4 by 3, okay? And now the state of n has again changed, right? The state was previously 4, now here the state has become what? 3, right? So initially it was 5, then it became 4, now it is 3. So when it's 3, again it will check the condition, and again it will go to the print function here, okay? So as you are seeing, we are not being able to go to this line yet, okay? We are not being able to go to this line yet. We are just coming here, we are firstly checking the condition, we are coming here and again sending the value of n by decrementing it by 1 to the print function, right? So after after we are in our state 3, right? The value of n is 3, right? So again it checks, it doesn't satisfy the condition, again it goes to the print function. So again when it goes to the print function, now the value of n is again changed and it becomes 2. So it is now 2, okay? It again checks the base condition, sees that it is not satisfied, so again it goes to the print function, okay? And now the value of n becomes 1, from 2 it becomes 1, okay? And again it sees that n is not satisfying the condition, since 1 is not less than or equals to 0. So what it does is again it reduces the value of 1 by 1, and now the value of n becomes 0. So n is now what? 0. So what will happen now? Here this condition will become true, since n is less than or equals to 0. So this condition is true, okay? So since this is true, what it will do, it will return, okay? And where it will return? It will return to the previous state, okay? It will return to this state, okay? So let me use another ink here. It will return to this state. So 0 will now return to state 1. And when I have sent when the value of n was 1, what I did was this line of code was implemented, right? But now since I have finished with this line of code, because I have returned here, right? So after I have returned here, what it will do is it will go to the next line, it will come here, and now it will print cout n. So what is the value of n right now? The value of n right now is 1, right? So it will print this. So in my output, say if I write my output like this, now I have what? I have 1, right? Okay, so I have 1 now, okay? Then what I will do, I will go to this line, from this line here, okay? Wait, let me use the same ink. Okay, so now I will return. Now I will return where? I will return to the previous state where I got 1 from. So when did I get 1? When was the value of n 1? So when the value of n was 2, and I have called this function 2 minus 1, then the value of n became 1. So I will be returning to the state where n was 2, right? So when n was 2, what I did, I implemented this function, right? Now I'll be returning here and I'll be going to the next line, because I have finished with this line, right? So when I return, you have to imagine this in this way. When you return from a state, okay, from a function, what you do is you immediately go to the next line where you have returned to, okay? So when you're coming in this state, n equals the previous state, which is 2, you will be going to this line, right? So cout, now n is 2, so you'll be printing 2 here, right? Now again what you'll do, you'll return, okay, and you'll return to the previous state of 2. So the previous state of 2 was 3, right? So when the previous state of 2 was 3, it has finished the implementation of this line. When n was 3, 3 minus 1 became 2, right? 3 minus 1 became 2. So this line is implemented. So what it will do, it will go to the next line, right? So the next line is cout n. So that is print n, right? So what is the value of n now? It's 3, right? So similarly in this way, it will again return to the previous state of 3. So the previous state of 3 was 4. So it will go to 4 here, okay? And it knows that when n was 4, this line was implemented, okay? So this line was already implemented, so it will go to the next line, right? So in the next line, it will print the value of n, which is now 4, right? So it will print 4, sorry, yes, it will now print 4. Okay, then it will again go back to the previous state of 4, which is what, which is 5. So now this n, the state we are returning is 5, and from 5 we already know that this line has already been implemented when n was 5. So it will go to the next line and it will print n now. So what is the value of n? It is 5, right? So 5 will now be printed. So this is how we are printing 1 to n using recursion IBH method, right? So here in this IBH method, this I is the print, right? So induction, we are printing, right? Then B is the base condition, the condition which becomes true so that we stop our recursion and start returning, okay? And this H, this is our hypothesis. So this hypothesis determines how we are implementing or manipulating our recursion function, okay? So hopefully this is clear to you. This is very easy. Okay, now let us see with a different example, which is the factorial example, how to calculate factorials using recursion. Okay, so let us see example 2. Okay, so our example 2, we have already defined it to be our factorials, right? So in example 2, we will be implementing factorials. So you already know what factorials is. So n factorial will give us n into n minus 1 into n minus 2 into up to 1, right? Like this. So factorial is a process by which we keep on multiplying its value with its value less than 1 until we reach 1, right? So for 5 factorial, we will have 5 into 4 into 3 into 2 into 1, which gives us 120, right? So if we want to implement this method, we could have very easily done so by using a for loop, okay? But what if we want to do it by recursion? How we will implement this through recursion? So in recursion, in the IBH process that I have shown you, right? In this IBH process, what we need a base condition, right? So what will be our base condition? Okay, so step 1, what is our base condition? So our base condition is the last, right? This one. So if n equals to 1, we will return 1, right? So this is our base condition, because we will stop, because here we cannot go further. When we get 1, we cannot go further, right? So we will stop when we get 1, okay? So this is our base condition, okay? So in step 2, what we have to do, we have to fix our hypothesis process, okay? Hypothesis. So what will be our hypothesis? So our hypothesis will be to decrement the value of n by how much? 1, right? So we will decrement the value of n by 1, okay? So in our step 3, we need to also know our induction method. So what will be in our induction method? So in our induction method, only reducing the value of n by 1 will not get our result, right? We need to find, or we need to multiply it with the previous state as well, right? So 5 needs to be multiplied with 4, this 2 needs to be multiplied with 3, this 3 needs to be multiplied with 2, and this 4 needs to be multiplied with 1, right? This is how we are doing factorial. So we need to do this as well. So how do we do that? Okay, we can very easily do that by multiplying, right? Yes, so we can do that by multiplying n with n minus 1, right? So this is our induction process. So how we will implement this in our code? Okay, let us see. Okay, so our code will be, say our code is int fact, right? And we are sending a value n here, okay? So here what we are doing, we have already set our base condition to be, if n equals to 1, then what we do, we return 1, right? We return 1, okay? Since below 1 we cannot find any other value, right? If we go to 0 and if we return 0, then all of it will be multiplied with 0. So that is why this is our base condition, right? Base condition. So once we get 1, we will return 1. Okay, so this is okay. Then what we have to set our hypothesis. Okay, so our hypothesis, what we have already said is, say we are keeping a value here in, say, temp, right? So we will be calling the factorial function, and in this factorial function we are decrementing the value of n by 1. So this is our hypothesis, right? And in our induction, since we need to multiply, what we are doing, we are multiplying n with the next element, right? So this becomes our hypothesis and induction process. Hypothesis and induction together, right? Plus induction. Okay, so what you need to be clear about is what is the difference between your hypothesis and induction. So in hypothesis, what you're doing is you're just calling the function. How are you calling your function? Okay, that is the process you're doing your hypothesis in. Okay, so here you're calling the function by reducing the value of n by 1. So this is your hypothesis, and your induction is what you're doing with the result that you're getting from after calling the function. So after you are calling this function, you will get a value, return value here, right? Here you will get a return value. So with this return value, what you're doing, you're multiplying n, right? So this is your induction process. Okay, then lastly what we do is we return the value of temp. Okay, so this is our factorial function. Okay, so let us check how this function is being implemented. Okay, so let us see while calling the function how n changes. So initially, what was the value of n? Initially the value of n was 5, right? Now when we send the value of 5 to our factorial function, firstly we check our base condition, right? So our base, this is our base condition. Okay, I have erased it previously, and this is our hypothesis. Hypothesis plus our induction process, right? So this is our induction, this is our hypothesis. Okay, so when n is equals to 5, what we did, we firstly check our base condition, and we see that the base condition is not satisfied, right? So base condition is not satisfied. Rather, what we are doing, we are going into our hypothesis. Okay, and in our hypothesis, what we are doing, we are calling our function factorial by decrementing the value of 5 by 1, so it becomes 4, right? Now the value of n is 4. Okay, in our factorial function, it will again check the base condition, and it will see that the base condition doesn't satisfy. So this will continue up to 1, right? So when we find the value of n is equals to 1, what will I do? I will return 1 here, right? Okay, so when you return 1, what are we returning? We are returning 1 here. Return 1 here, right? So when we are returning 1 here, what is the value of n? The value of n is 2, right? So what we did here in our previous state, 2, this was 2 times 2 factorial of 2 minus 1. So when it called the factorial function 2 minus 1, the value of n became 1, right? The value of n became 1. Okay, and it checked the condition, and the condition became true. So what it did, it returned 1 to the previous state, and the previous state we knew that n was 2, and here we get the value 1, right? So the value here becomes 1. Okay, so what we are doing essentially is we will be returning 1 when we get the base condition, when we reach to the base condition, and the 1 will come here. Okay, it will come over here. Okay, and the previous value where we got 1 from for n was 2. So now what will happen, we will multiply 2 with 1 and get what? We will get 2. So the value of temp is now 2. Okay, so what are we doing? Then we will go to the next line. Okay, we will come to the next line, and we will return temp here. So what is the value of temp now? The value of temp is 2, right? The value of temp is 2, and it will return 2 to which state? It will return 2 to the state when n was 3, right? So the value of n here is now 3, and when we send factorial 3 minus 1, okay, the result we got here was the result that we are returning temp from. So we are returning temp, okay. The value of temp is 2 and we are returning this temp here. So now we will have 3 into 2, which is 6, right? So the value of temp is now 6, right? So the value, okay, let me erase this. The value of temp now is 6, right? So now this 6, where will it go? This return temp, this return temp will go to the function where it was called from. So it will go previously to the function where it was called from. So previously when the value of n was 4, okay, when the value of n was 4, we called the factorial 4 minus 1, right? So this 4 minus 1 became 3, and when n was 3, okay, when n was 3, what are we returning? We are returning 6. So this 6 will be returned here, right? So if it's returned here, now this 4 and 6 will be multiplied. 4 times 6 will be multiplied, it will give us 24, right? So this 24 is now saved in my temp here, right? This is saved in my temp. So this temp, where will it return? It will again return to the previous state. In the previous state, n is what? N is 5. So when n was 5, I called the factorial function here, and here 5 minus 1 was what? 4. So when this n was 4, what did I return? I returned 24, right? So here I will have 24 when my n is 5. So now what I'll do, I'll multiply my 5 with 24, which will give me 120. Okay, so what are we doing here? We are getting the factorial, and how? We have set the base condition, which is n equals to 1, then it will return 1. Okay, and when it will return 1, what it will do is it will go to the previous state, okay, and it will multiply the current value of n of the previous state with the return value. Okay, so initially when I returned 1 here, I returned 1 to the state where n was 2, right? So I returned 1 to the state when n was 2. So I calculated temp, the value of temp, as 2 into 1, right? It became 2. Now I will return this value 2 to the state when n was 3, right? When n was 3. And what we did 3, which is my n, into fact of n minus 1. So this 2 will be returning to the function where it was called from. So this 2 was called from fact n minus 1. So that is why we are multiplying 3 into 2, which becomes 6, right? Then we return this 6 to the function where this was called from, and this was called from fact 4 minus 1, right? Here fact 4 minus 1. So what are we doing now? We are multiplying 4 with 6 now, okay, since 6 is returning to the previous function where it was called from. So now 4 into 6 becomes 24. Okay, now this 24 is being returned to the function it was called from. It was called from the function fact 5 minus 1. So now temp will be, the value of n is 5, right? So 5 into 24, 5 into 24, which becomes 120. So hopefully this factorial problem through recursion is clear to you. Hopefully you have understood. This will be all for today's class.